Good afternoon, everyone. Myself, Kaushik Beda, Assistant Professor of Civil Engineering Department at HIT. It's my pleasure to introduce our speaker for this session. We warmly welcome Mr. Indrajit Borua, Assistant Professor in the Department of Civil Engineering at Jadavpur University, Kolkata. One of the India's most storied and respected technical university with over a century of excellence in engineering, education, and research. Mr. Borua completed his Bachelor of Engineering in Civil Engineering from Jadavpur University, the very institution where he now teaches, and went on to pursue his MTech in structural dynamics from the Indian Institute of Technology, Roorkee, one of the oldest and most distinguished engineering institution in Asia. His research interests lie at the intersection of classical structural engineering and modern dynamics, specifically in dynamics of structure, earthquake resistance, design of structure, and energy attenuation of vibrating system. These are areas of immense relevance as India contributes to build resilient infrastructure in seismically active zones. What makes Mr. Borua's perspective particularly valuable in his breadth of experience spanning over 10 years across industry, academia, and research, and he brings both theoretical rigor and practical wisdom to the classroom and today's session. In today's talk, he will explore the application of machine learning in emerging civil engineering trends. This timely forward-looking topic is transforming how we will analyze, design, and manage civil engineering infrastructure system. Please join me in giving a very warm welcome to Professor Indrajit Borua. Sir, dash is yours.
Thank you so much. Uh, I'm audible, right, sir?
Yes, sir.
Okay. So thank you so much, sir, Kaushik sir, for this wonderful and warm welcome introduction of mine. Also, a special, very special thanks to Dr. Shoptoshi Roy, who specifically started the communication, and thank you for the organizing committee for giving me this opportunity to connect with so many wonderful people who is working for this profession. So I'll just share the screen and start the session for today.
Okay, sir.
Yeah,
Please proceed.
yeah, thank you. Okay. So let me do the full screen. Okay. Is my screen visible?
Yes, yes, sir.
Okay, thank you so much. We'll give a talk. So myself, Professor Indrajit Borua from Jadavpur University, and I'm going to give you a talk on application of machine learning in emerging civil engineering trends. So we'll start with very basic, and then we'll go for some really relevant and simple examples to start the process or to explore these contents. And I have obviously most people know that there are so many wonderful contents available on these machine learning tools and how to apply them in the internet. Those are available to learn. So specifically, I focused on some specific motive through which a person, if he wants to start these machine learning tools for different applications, they can also start. So we'll go for some examples as well. So let's start. So primarily we will be going for some keywords which we'll be using throughout the presentation. The first is we'll be using the AI for artificial intelligence. We'll be using the machine learning, ML for the machine learning, and we'll be using DL for deep learning. So these are some of the abbreviations that today these are also the buzzwords. We all know that. Moving on, so we have some specific global goals for sustainable development on which we all are working as professionals. So here, with respect to the sustainability goals we have, primarily it is said that there are total 17 goals which we all are devoted to working with on through different professions. So here in my lecture, primarily through all these 17 goals, I will be primarily focusing in some content. In some of the goals, it will be totally connected in more sophisticated manner, and some will be partially connected. Primarily, we will be focusing in the ninth one, which is the industry innovation and infrastructure. And here we have the specific content of that with respect to the global goals. So now moving on to the content. So here if we start, we will be primarily focusing in three different segments. So this lecture is primarily the classified in three different segments. We will start with why we will be using these machine learning applications, why nowadays this is a buzzword. Then we will be going for what are these machine learning applications and how the tools are useful. And then in the third one, we will be doing that how exactly to apply them. So in these segments, I have just divided my lecture for today. So after the end of this session, there are certain outcomes which I am trying to address. The first one is the audiences or the attendees may appreciate the necessity and significance of available generatable data. Now, next is they can acknowledge the necessity of AI, ML, DL, artificial intelligence, machine learning, deep learning, for different real life applications. Third is they can explore the applicability of these in the different engineering applications, specifically for in our domain as well, and then to apply the concepts and methods and tools for of these for different specific applications of different specific subdomains as well. So, so let's start with the first one, which is why. So there are four segments, four specific things I want to address. First is why AI/ML, and then why now suddenly we are about to do that, why now it is important, why now this is the buzzword. Then why us, because we are civil engineers. Then why us, how it is relevant to our field. And the last one is what if we don't, then what will be happening. So to address that, let me tell you that obviously we all know that there is so much of available data of so many years of civilization. We have done so many things, and as the mother stream of the engineering, that is a civil engineering, we have so much generatable data, so much generated data, experimental and all the simulations we have, so much design data we have. We have it in our libraries, we have it in our computers, we have it in the cloud base and different portals as well for different type of deep web, etc. Or the surface wave we generally use. So here if we proceed, the data is relevant for all the disciplines, starting from the atomic level to the celestial level. The type we have explored till date, it is relevant for for solving a puzzle, for finance, for navigation, for medical, law, engineering, medicines, and forensic. For example, I'll just start with just few examples. I've just put different examples in the throughout the presentation. So if we start one of the example of the recent forensic example in India, Punjab, the police, they have already they have just introduced some AI powered voice recognition system, and they caught a criminal with respect to that. I mean, using that. Okay. Also, in this Republic Day, basically the Delhi police, they deployed some machine learning introduced machine learning enabled, or that is AI/ML enabled smart glasses for the scrutiny purpose. So from the criminal database, they can scrutiny. So with respect to that, because they have so much data which we can use, and in many soft corners, in many specific finite and minute operations, a machine can work much sophisticatedly. Obviously, in some countries there are some mishaps, but still it is they are working. The data is also generating, and people are still working on this. So now what we have few components here, like the collection of data. That is important, obviously, for implementing any of it. We have we can do the analysis with the data. Then we have we can process the data, and with respect to how we process the data for specific applications, can understand the data, and we can make a machine understand it so that it can do the work for us. So so that is the science, what we call as data science, that is to extract the knowledge and insights from the data. So we have the data, we do statistical analysis, and then we do the machine learning. And so the machine can learn from the executable data or the existing data. So so why now we are suddenly doing it? So typically there are few industrial revolution we all know. The first one is for the mechanical systems, where we had steam engines, and we have other applications where these type of mechanical systems introduced. In the second one, we got light. That means we got the electricity and other applications through which we in the electricity based revolutions are there, and the technology obviously followed the same for different new innovations. For the third industrial revolution, we got IT sectors with, because the computer was the I mean more available, and we could access it for solving different type of problems. And now at the end of the this one, we have the fourth industrial revolution, where we have this type of cases where we are working with the system in the cyberspace. So either we are working from of a system in our world, or if we are going forward for the outer space application, or we are going for the colonization for the future generations, or with respect to the mankind's next progress. These trends goes on, and the degree of complexity increases. So with respect to that, we can go for some very recent recognition. That is in 2024, it is the first time that we got two Nobel Prizes. Our science and technology community got two Nobel Prizes, which are based on the machine learning AI techniques. So this is the first one on the Nobel Prize on physics. And in the same year, we got for chemistry also, where the work was specifically based on the Nobel Prize work on the chemistry was specifically on the machine learning applications. So in the technology also, we are not far. So here, what are the things? Let's explore that. So here, four segments. First is, what is this AI/ML? Then what can we do with AI/ML, the artificial intelligence machine learning, to repeat. What is being done with AI/ML so far, and what can we not do with it? Okay. So there, with respect to these things, if we start understanding the concept from the very basic of the biology, how different thing works. Like if we ask the question to ourselves or our kids, that how a sea turtle knows that to lay eggs, these are the specific locations, or when from the egg the small sea turtle, the baby sea turtle is coming out, how it knows that he needs to go to the sea in this specific direction without any guidance. Or if we ask the bird, that if we ask for the to ask that how the birds understand that she needs to make a nest for the babies, for the eggs. So we find the answer that it is primarily the instinct in our genetics, in our DNA, which are telling us what to do in different circumstances. So from that, the concept of algorithm comes, specifically how all our human body system, starting from the respiratory, digestive system, and everything goes on. So that is specifically the step-by-step procedure that we follow to do different type of things. So now it is wonderful to know that how the birds, how the trees algorithm works, because they are here from I mean before million years of the evolution of humans or other animals. Okay, but it still goes for certain algorithms, because we do not see it has some smelling or seeing capability the way we see or the way we smell things. But still, it can attract by beautiful, colorful flowers and smells, etc., etc., to continue its generations and continue its own reproduction system. So this is one of the picture from my from our roof, actually, of our house. So from there, different type of uh, animals and plants have some specific ways that is there in their DNA, or we learn. So, for example, the octopus's vision is not so good, but still it can camouflage beautifully because of the type of genetic mutation and genetic changes it has already done. So it happens for all the type of predators, all the type of race of these predators, and all the type of animals. Now, when we interact with the environment, and we also talk about the interact with the humans. Like right now, I'm trying to interact with the attendees who gave their respectable and valuable time to me for this lecture. And obviously, I'm talking in a term so that I expect that you understand. So that is how we humans are communicating, or the same how we are taking a class, or how a student is asking us questions, etc. So now let's go for how we started communicating with machines. So obviously we started communicating with some binary things, like if the light on and off, that is typically one and zeros, how we are communicating. And now little bit complex systems like monitors, and cameras there, or in nowadays we have more complex systems like smartphones, computers, etc. So what happens after humans invented machine? In first time 1950, in one of the research papers of Alan Turing, he has actually proposed to consider that if machine can think, so that is one of the legendary and legendary milestone we have, from which the discussion came up. And after that, there was 1956 Dartmouth conference, which is where the people discussed about it, and that is the era of the AI when it started. And from there, this is one of the legendary and one of the significant event in the history of the machine learning. And then in 1955 to 56, the logic theorist was there, which was told as the first machine learning enabled AI program. And though still then people are working on it, and nowadays there are obviously movies where it was there was a pretty accurate depiction what we call we see nowadays. And what when I teach about I teach about these technological innovations, like what we can do with the computers to my students, then obviously I give an example of a baby. Like the computer works like a very smart baby. I mean, it doesn't know, but if we tell it what to do, obviously it can act accordingly. We need to communicate it like a baby. But once we do know how to do that, it does it in a very sophisticated manner. So moving on, so how we communicate is through our senses. We have different senses how we can interact with different systems like other humans, other beings, to the environment or to the computer itself. So there is a specific difference between memorizing and learning. Like for example, in memorizing, we are specifically collecting the data and we are remember it, we are stacking it down. Okay. And for the learning process, basically the things are different. Like when we are processing a data, and we are understanding the thing, and we are having some ideas from this. So if we just give an example, like that's why I shared my full screen. So if I just go to MATLAB, and here if I say that a equals to 5, so obviously it knows, it is now remembering it, it is in their memory. Now if I say b equals to 10, so obviously it knows. Now if I ask how much is a, it will tell it is 5. If I ask how much is a plus b, it will tell it is 15. Now if I tell it to remove all the memory, clear all, and let's clean the disk space as well. So now it doesn't know. Now its memory is empty. Now if I ask how much is a, it doesn't know, obviously, because this memorizing actually works with the type of stacking the memories. And obviously learning is something to interpreting it, which we will be learning today or we'll be discussing today. So primarily the memorizing includes the what component, and the learning includes the why and how component to understand the patterns, etc. So that is how we work with it. And artificial intelligence is a branch of that enables machine learning, machines and software to simulate human like cognitive functions. Because we are human, that way we interact, we can try a machine to learn that, to teach that, okay, or to train with respect to that, so that the learning, reasoning, problem solving, and decision making can be done. So there are four type of machine learning domains primarily. That is, the first is the supervised learning, where we primarily learns from the labeled data set. It is obviously supervised. There is unsupervised learning, where it discovers hidden patterns, and the full algorithm or full process is not supervised. There is semi-supervised, which is a hybrid part, which is between the supervised and unsupervised learning. And there is the reinforced learning, where we are from the penalties and reward system, it understands what to do, and that is the learning process called reinforced learning, right? Like it is used in the chat bots which we are using nowadays. So how do we know that how intelligent is artificial intelligence? Obviously, intelligence is a very general word. For humans also sometimes we use, but obviously, how much is the intelligence? So for that, there are three segments, three different categories. First is the narrow AI. That is that is in a very narrow level, which is the recognition of voice, etc., etc. There is general AI, so it can do works when the intelligence reaches to a certain level where it can do tasks that a human can do. And third one is super intelligent AI, where it does with respect to it can surpass the human intelligence for some specific activity or some specific domains of activities. Okay, so everywhere we have some classification. For example, the levels of human civilization, that how much we can do. There is also a link from the how much we can take energy from the from our own star. So that is one of the definition how the humans have defined the class of human, civilization, that how much developed we are. Okay, and obviously if you explore that scale, we are actually in a fraction right now. But this is how we need to know that how the levels of artificial intelligence are there. So there are many techniques. So we'll be just, as the time is limited, we'll be starting from different techniques. So there are some traditional machine learning techniques. Okay, and these are easy to access nowadays. So like linear regression, logistic regression, decision tree, random forest, and there are so many nearest neighbors, etc. There are some foundational neural networks that can be built from the machine learning domains. For example, the artificial interneural network. And in our today's class, we'll just try to explore. We'll just explore some examples also from the very basic level, from of the previous traditional conventional mention methods, as well as the neural networks. We'll also try to do some examples. So it here basically there is some input layer, some then we have some hidden layers, and there are some output layers. Now I'm not explaining because in the example I'll be explaining in much further manner. And there are some specialized deep learning tools also we have, like the convolutional neural network. So these are specified. And we have some generative and creative models, like what we can classify in the segment of large language models, diffusion models, etc. So, and we have some strategy and multi-input models like reinforcement learning that we already discussed in the categorization, and there is a huge domain of that, multimodal models, etc. Another example of the medical domain before we delve into the engineering, civil engineering examples, that is the medical science and applications. So right now, so there are a few minute things which machines are trained for, how it understands different properties, and it can give you outputs from different inputs we provide. For example, in China, what they have done is in different shopping mall centers and different places, they place this type of kiosks where if you enter, there are some recommended things from the AI for the basic medicinal purpose and basic treatment. And if it is critical and it cannot solve, obviously it will be connecting you to the doctor. So there also the ratio is not how they expect for the doctors versus the patient. So they have invented this, and it is pretty much useful in certain places in China. In different countries, they are also planning for the same. So there are specific ways how they how they work it. So let's see that how we can delve into that, and how we can categorize things, and how we know that how thing works. So the first is the artificial intelligence, which is the a domain of the data science. Basically, it enables the machine to mimic human-like functions like reasoning, problem solving, or making decisions. And in this, there is a subdomain called machine learning, which we will be focusing today. And here we have the some specific the approach of AI it is, where it finds its own patterns of data to improve its performance. And the third one is just within it, that is the deep learning. And here we have the so for a specific neural network type of models which has multi-layered systems to solve some specific problems for the recognition and understanding. So when we play a chess game with a computer, or when we roll a dice for when we roll a dice for some specific game, we primarily you introduce some randomness and some algorithm how the computer plays it. Its moves are always not the same, and there the some machine learning is used from the very old chess programming. When we type something here purposefully, I have written it wrongly, and it is correcting it. I think that many of you also do that. So in a quick manner, when we write, sometimes we do these mistakes, and it corrects it with its huge data set that the Google search engine or any other search engine has. And it obviously follows the machine learning algorithm, how it corrects you from a wrong spelling to a correct one from its understanding of data. When we drive a car, obviously the car can be stocked with respect to some self-driving car applications with respect to that. So when it knows that this is the part, then obviously it stops automatically with respect to the given data that it has, that it knows, because it is a safety issue. So there are sophisticated machine learning models. when we use our smartphones for the patterns of our fingerprint or the face recognition to unlock the phone, so obviously that is also some machine learning algorithm involved. Basically, it has some actual data, like actual data of your fingerprint or your face recognition, and the way it understands it is with respect to the predicted data. It shows that how much it is far from the actual data with respect to the error analysis, and with respect to that, it's judged whether it is acceptable or not. The way it processes the actual data and the new data that you are feeding, it understands and it gives output with respect to that. So moving on, the that is the last component, that is the how component. Will be spending more time on this specific component to understand different applications of machine learning. So here we have a different segment, that how to start with the artificial intelligence and machine learning, to have fun start with the domains we all work for. Next is how to use the AI ML as a tool. So we'll be developing some, we'll be seeing developing some algorithm in a from a very basic manner with examples, and then the how to apply this AI/ML for general applications. So I'll also show you one of the neural network which I developed for a very general stress analysis, whether it can find or not. And then I modified it for a transportation problem for super elevation. So I tried to reach few of the domains, though my domain is structural engineering, but still I just tried to access some very basic problems where the outputs are already known to us, just to check whether these algorithms are giving the correct answer or not, and what are the tools, what are the controls we have to improvise that. Okay, so moving on. So first, before we start, we need to check whether we are equipped or not. So the first is whether we are equipped or not. I mean, we are sitting here and we have our computers and smartphone with us. So do we need to install anything? How to start with it if we want to start? What are the where are we knowledge wise, and do we have the tools to use it, or we need to do something? We need to take license or something. Or the next is, are our resources useful, which we are exploring or discussing so far or learning so far. And the last one is where to start finally, if you want to start, if for the people who want to start from the machine learning tool. So obviously the answer of the first one, which is are we equipped or not, if we see the Apollo mission, which is in the 60s, it is done. So humans first time went to moon. There are different opinions on the technical background of it, but still successfully we can say that there was some specific process of outcomes, how people have reached moon. So when the astronaut reached it, there was the control engine, and in the Apollo mission, we see that the RAM and the ROM that is used, that is, I mean, much more lower than what is there in our smartphone. If you have a smartphone, I'm pretty much sure that it is obviously having few hundred times better RAM, processors, and ROM of that system. But still, that system is specifically modeled. The AGC was specifically modeled for the uh, moon landing. But still, the that is the processor's power, the RAM and the ROM that led the humans to moon. That was the first time in the Apollo guidance computer. So obviously, are we equipped? So yeah, definitely we are. And without installing anything, also how we can start exploring different problems, that also we'll be discussing here. Because obviously there are different resources, how we see different problem specific definitions. But here I'll be just showing you some very basic algorithm which you can apply with some tools without installing anything in your computer primarily. Okay, and some I will also show what we is already installed things for that which you need to install something. Okay, so both we will be discussing for one examples of tools. So obviously now the list of the things, which is where we are knowledge wise, do we have the tools or not, are our resources useful, and where to start. So let's start with these discussions. So let's start exploring now with some very general problems. So that was a very brief introduction because of the because we have limited time. But to start exploring, I'll start with very simple example which I think all of us can relate. So here we will be going exploring some functionalities of the machine learning tools, and we will be seeing different applications related to the civil engineering primarily. Uh, and we will be going through some machine learning tools for some standard methods with some known examples we already have, to see the applications of these in our known domain, for which the answer is always already known to us. Obviously, that can be used for many applications where we cannot directly define or directly derive some expression. There also we can use it once the machine is trained and it is giving us continuous good output. We can check that, we can test that. So with respect to this journey, we will be going for different segments of examples. Like first, we will be going for some example which is called which is based on the basic optimization problem using the data science tool. Okay, so in the first problem, we will not be using any libraries or any things which we do not know, I mean, which we need to install from the data science domain. The first problem will be pretty much mathematical, which we already know without any understanding of deep machine learning. So let's go start with it. For so gradient descent is something which we all know. It's a mathematical tool, and we'll be using it. We use it for engineering optimization. So here the training parts will be discussed. So primarily, if we see that if we have a target at the which is at the bottom, and from the top of the hill, if someone needs to go down to this specific point on in different paths, so obviously we can go for the in the next part. So this person who is coming from top to bottom, you can see that obviously we are coming near. As we are coming near, obviously the distance is reducing, that we will be representing here in the mathematical data science applications or the gradient descent application as loss function. So from this track, if we just try to do it in more sophisticated and detailed step manner, then this is how we will be getting a graph. Okay, so this graph is plotted in Python for some specific application. And here we can see that obviously it is rolling down to the zero where the loss function is becoming zero. And we are going to our destination. We are reaching to the specific answer that we are trying to find. Okay, in a specific part. So that is the gradient descent. So we know that as we are going down, our loss function is actually reducing, and from the bottom to top, we are just having new positions, and with respect to that the loss function is reduced. So this is the loss function, which we can see that it is reduced and it is finally becoming zero. So let's see if we can do that for some specific application of the column. So this is a very basic design example. I purposefully have taken something very basic. For different complex research examples, obviously we have a lot of research papers in the internet, but here I'll be just focusing from the very basic. So here this is a column. Here some load is applicable. Okay, the load I'll be discussing. Here the shape of the column is circular. The column of the grade is concrete, and the concrete grade is the M20, and the factor of safety used is 1.5. And obviously I can customize the load in the program itself. And here, with respect to the column length, we can find that if the column length is fixed, how to optimize the diameter, because it's a PCC, there is nothing much. And with respect to that, we can understand that if it can take the load or not. Obviously, so there are, for normal load, I can simply divide it by the strength of the concrete, the compressive strength, and I can find the area. So here, to make it a little bit more relevant with respect to the gradient descent example, I purposefully introduce the self weight. That is obvious. And as we are optimizing the system, the self weight is increasing. And so that there we have the opportunity to create a loop just to make it relevant for this column example. So what I did is basically this is MATLAB. MATLAB you need to install, or if some free time limited versions are there. The first example we have is on the MATLAB. Here you can see that we have defined the load and factor of safety. Obviously all the things we have written, the height, the density, that is for the self weight we need, and the gravitational acceleration in I mean obviously in SI unit, and the sigma allowed is given for M20 concrete. So I have written this code. Now we need to optimize the parameters using the tool as like that is the uh, gradient descent. May not be the too much sophisticated algorithm, but to start with the discussion. Okay. So here in the learning rate of this an iteration this, if we start with the initial guess diameter of D, that is 500 millimeters. Okay, the units are missed somewhere when I have written it. But still, for that also, if someone wants, they can take the help of Copilot or AI. So it will be definitely fixing it properly in some of the places. So this is 500 millimeters we have started with the units, and now this is the part where if the data is in a loop. So from the very beginning with the initial guess, the iteration is done, and in the gradient descent it is actually testing whether each time how much is the gradient, and it is seeing how much is the loss function. Once it is going, it is just repeating the process till it reaches the updated diameter, which is much closer than what we expect, and it is having the loss function 0. Okay, so simply it is done that way, and at the end we it is found that this is how different predictions are done. So okay, my mouse pointer, okay, here is the pointer. So here it started with the initial guess 500 millimeters, and in different steps it started learning, and still the loss function is 0 till it is reaching the final part where it is more optimized. Through the gradient descent it is reaching to the final result, that is here, which is 446.469 millimeter. Okay. That is pretty much optimized. We do not need to do the trial and error because it is doing it in the specific learning rate just to start with the process. So this is the warm-up problem primarily, just to understand from some of the very basic gradient descent example. So this is one of the optimization problem, the basic one. Now the next one which I have included is the application of machine learning tools through the different examples. So here we will be diving into the machine learning tools which we generally use for different applications. So that I know that from different domains people are there. Generally for these sessions I generally try to convey some of the, for if when it is for the student participants or some other people, I generally circulate a form, pre-session input form. But here, as I know that all are professionals, here I what I wanted to include is some very much generalized problems. So here we know that planning is a part of our domain, and here the price of the plot, it is relevant to everyone's life, whether someone is engineer or not. If he or she is uh, trying or wishing to buy a property, maybe. Okay. So in that case, it can be a relevant general problem where we will see that can we create a model to predict the price of a plot. So it is not a totally perfect model, but to start with, I have reduced the complexity. So how we have reduced the complexity? Here, only with respect to area, I have included some price of some specific plots. Forget about the location and other attributes about the functionality. Initially, let's say that if I train the model that if this is the length and breadth and this is the area, then if this is these are the prices. I do not have the other data now. So with respect to that only, if we want to put an want the output from any machine learning technique, so how we do that? So the first example is done through the linear example. So here, in the linear example, we have the straight line equation y equals to mx plus c. This is a plot of y equals to mx plus c in MATLAB. In Excel and any other platforms we can do. Here we primarily have the slope and intercept, and y and x we will be using as input and output. Like the x we will be saying as the independent variable, maybe the area for our example, and y is the dependent variable that I'm telling the machine that this will be dependent on that. So obviously the prices won't be independently, it won't be exactly dependent on the independent variable. Otherwise, it's not a direct function. It depends on so many things, the plot of the price. But here, with respect to its understanding, I told the computer for the linear, if I tell the computer to do a linear regression model, so how to start with that. So here we have some very powerful tools, and this is done in Python. I do not use Python in some Jupyter notebook or those areas, the those tools. Here, all the examples that I'll be showing you is done in the Google Collaborative. That is the Google Colab, where I mean, me and my team sometimes interact through different coding, or I do on my own for these small examples when I created. So here, it is done in Google Collaboratory in cloud. It basically runs, but for these problems runs pretty much fine. So here, some tools are used. like pandas will be using, numpy will be used, matplotlib will be used, and sklearn from the linear model will be used. Okay, I mean linear models from sklearn will be used for these examples. So these are some, this may find you may find it something new if it is new to you, if this domain is new to you, in that case only, because it was new to me, many time back. But what happened is I was very conventional about some writing techniques, that how I learned coding was primarily with respect to the basic applications and the specific linear models. And when I used to solve dynamic problems in the initial days, and even just before few time, then I was very comfortable writing everything on my own. Maybe some very intrinsic, very much basic intrinsic libraries and functions are acceptable for me, were acceptable for me. But other things I was always wishing to write from the scratch. Okay, but here after some time, when we are comfortable about it, I found out that there is a famous say here also: you do not have to reinvent the wheel, just attach it to a new wagon. So obviously we every time we cannot start everything from the scratch. Maybe we should not start unless it is some very sophisticated model where it is case specific. For certain cases we will be using the some of the functions and libraries directly if we know that what is happening inside. Okay, so that is the purpose of putting this slide. So that's why we will be using some basic libraries, which are the famous one for the machine learning applications, and we will be making the system understand the data and to interpret that. So let me discuss, because we will be using it, so I'll be just giving you a very small introduction of these. So pandas help in the data manipulation and analysis. So here I have the price of the plots in my Excel file in my computer. So from that I just want to take the data, and I want to manipulate, and I want to change the data in my workspace of Google Collaboratory for this example, for using Python. So for that pandas I have used. Then we have the numerical computing tools like NumPy. In MATLAB, some of the mathematics and math toolbox or the NumPy is already there. You do not need to add something else. But in Python, basically these are pretty much popular for numerical computing. Then we have matplotlib. This I've primarily used for plotting, and we have the sklearn library, which is the machine learning library. And there, as we are doing linear regression, the linear predictive model is just imported from that. That's why these things are there. Now, so now I have something in my laptop, in my computer. I have the data of these prices plots, which I have just discussed. Then I am just importing these tools in my space, so that it understands that these are the tools. Now I will be using this PD as pandas. This you will be all getting all this if you are starting in Python. But obviously there are so many good programming language platforms. So even if you don't, then you can just invite the data from your Excel sheet. So this sheet was in my computer, and now it is in my workspace. Using pandas, I have just fetched the data from my workspace, from my computer to this cloud workspace where I am working. So I have the data now. Next is I just want to see the data. For example, here if you see, so in x-axis we have the area, in y-axis we have the prices. Obviously there are so many factors, but as I said, this is a simple example. So here you can see this is having significantly less area, but the price is higher, maybe due to location, maybe something else. For now we will be just focusing in some inputs and outputs. For example, here we have just plotting it for this specific commands. So it is plotting the data, so that I see the data, how it looks, how it is scattered, how is the distribution of the data. Once it is there, I started with very basic, very less data actually. Okay, it is in different schemes. It demands so much of data, but I found it suitable just to start the process. So I have very limited data here. So now I am starting with the machine learning model. So just these two lines gives me the linear regression model to train it, and I need to tell that which is the input, which is the output. Okay. So in the fit here, reg fit is the line where from the data one is that data, just this data is data one, as we have seen. And here I'm just trying to do the linear regression just to tell that this is the input and this is the output. And once it is trained, I can ask the system that for this area, what you think should be the price, not telling it all the other attributes. Okay, so let's say it's for a specific location or for some grids or something like that. Okay, so this is the regression predict. We'll do one advanced, a little bit advanced one after we do this. So here in regression predict, I told it to predict 150 meter square of plot, and it gave us some specific price, which you can see in the outside, in the right side. Then I asked it for 200 meter square, and it gave me this because it is trained with the data, and it will be giving you something. For sophisticated problems, definitely testing is another tool. How we test a series of data, whether it is correctly giving or not, and then you can go for some new thing which we do not know. Okay, so there are three different data, and this is how it is giving the prediction with respect to that. You can also plot the same to see how it is behaving, and it is totally dependent on the data, how you feed it. Here I strategically have taken the data very much specifically and limited just to show the example to you that how to work. So here, if I run this, we can see that there are some specific linear model. So I can also see that how it found out it. So there is a best fit curve, obviously, for the straight line, the best fit the straight line. And with respect to that, it is it is creating and it is checking the outputs with respect to that for the prediction model. Now the applicability, that is the price of the plot only dependent on the area? Obviously not. It is also dependent on the aspect ratio. If the plot is not properly rectangular, maybe one dimension is too much. Maybe the road is nearby for some of the plot. Maybe some facilities like hospital, transports, etc. are more near to some specific plot. So obviously only by area it is not dependent. Obviously the legal grounds and other things are also there. So I thought of introducing one new problem for the audiences, so that you can also explore it with some modified trials. For example, if you do not have one variable, if you have multiple variables like x1, x2, x3, x4, etc. So for that, we will be using multivariable regression analysis. So here, obviously, for this example, the type, location, facilities, convenience, etc. are obviously a think of that. A price of a plot is dependent on these things. So obviously to simulate it, we can introduce so many type of things. So I cannot introduce so many variables because of the time constraint also for this example. So I simply have added one column called rating. So based on all the other aspects, let's say that in some certain platform, there is some rating given to some specific plot. So with respect to that, you can see that the price obviously goes high, and the price obviously can go low. The prices can be a factor of the rating, and the rating can be a function of different things like the where the plot is located and what are the other things of the plot, the facilities and the location and the accessibility, etc., etc. So with respect to that, now we have two variables. One was always, I mean, two inputs. Area was already there, and right now we have the rating also in our analysis. So now I cannot work with one straight line. Now I have two variables. So I need to go for multi-variable regression analysis. So same model I'll be using, exactly same thing. I'm again importing those things. I'm again taking the data, and you can see this time it is data. I just named purposefully as data 2 so that we do not mix up with the previous example problem. So here there is, you can see the another column is there, which is the rating one, which is okay, which is this one. This is the new column which was there in my Excel. So I've introduced, and I can also introduce it directly in here in the platform. But there I have done it purposefully in the Excel, and they again with the same pandas I have used to import it. And now same model is there, which is the linear regression, but this time there are two variables. Here you can see area and rating at that line as input, and as output we only have the price. So I'm telling it to train with respect to the given data. The more data you have, the more better scheme you use, the more relevant output we will be getting, because the tools are too much generalized for everything. So we need to sophisticatedly using it for our own applications, how we want to explore our problems. So here we have two variables. One is area in meter square, another is rating, that is like from 1 to 5. Yeah. And output is the price in rupees. So this is variable 1, which is area, and the variable 2 is rating. And here we have, obviously, you can see the prediction model. Here, when I'm telling the regression model to predict, I need to obviously give two inputs, because obviously it will ask me how much is the area and how much is the rating. So I have put the area of 248 meters square this time, and rating as 3 out of 5. And with respect to that, it is with respect to the trained data set, it is now recommending me a price that it should be the price of that plot. Okay, because this time two variables, so in comma I need to put two inputs. Similarly, I have done it for another prediction, and I have done it for another prediction, and I have done it for another one. And just the difference is, you can see that here with respect to that, from 4.8, when I'm increasing to 5, so here some price difference is there, which is may not be suitable for our understanding. So that can vary. It is how it is training. It is approximate. If I feed it more data, it will be accurately predicting it with respect to how I am telling it to behave. So that's why purposefully I have given that thing to just to show that here it is showing a reduced price, but it is not so far 4.8 and 5, but still it is reducing. So it is not like the standard interpolation what we do. It is specifically not the standard interpolation, but the machine's own understanding on this model with different factors. So it is not directly derivable from some linear interpolation that we do, because it is linear regression. So now we had some application on machine learning tools through examples. That is, we started with the linear regression, single and multi-well variable. Now let's go for something a little bit more detail, which is where we will be understanding the applicability of the data with example. Because in the last example, we have seen that it is obviously predicting something, but in some of the cases, we cannot relate with respect to the given data, because the set was very small. So that's why, to explore the applicability of data, I tried some example for this presentation, and I'll be showing that. But the thing is, here we'll be using some other algorithm, because with respect to the applicability, it varies a lot. For example, if I just, this is one of the rainfall data diagrams. Okay. So here we need to see whether our data is enough or it is useful or not. So here we do not have a very detailed plot. So this is in Kolkata region, the rainfall from 2014 to 2023. I mean, before few months also, I asked the one of my known person from the irrigation engineering department just to just when the 2024 data will be uploading, because it is 2026. Now I do not know, but few months back it was still not there, but they were working on that. But with respect to that, when I was plotting the data, rainfall data, then I can see the monsoon seasons variation. But the variation is like this. I cannot predict much things from this. If I want to see the upcoming monsoon season, just say that when I should bring the umbrella. It is obviously very much unpredictable nowadays for us. So sometimes I'm missing the umbrella from the office and from my home. But anyways, the through this plot, only by the monthly data plot, it is not so easy. Maybe in some months, 28th or 29th, maybe it rained heavily, so it went for the previous month and not the next one. So obviously we need more detailed data. So for this data is good, but it is not for the type of models which I thought of for predicting some monsoon seasons for the future. I need more data and a more sophisticated data for this purpose and application that I am wishing to. And I have also seen that there is some machine learning module on the hydrological models and water resources. So I didn't explore this further. I just thought of showing you this just to see that I didn't use this data, because I didn't think it is compatible or good enough for some prediction that I want. So moving on. So this is one of the things which I can. This is some generatable data. Like this is a structural dynamics example where the mass stiffness and viscous damping coefficient is given. So with respect to the damping ratio, I can find out. I mean, with respect to these things, I can find out the damping ratio of a system. But this relationship is known to me. It is not known to the machine. If I tell the equations to the machine, it can definitely find out. But if I tell only the data, then it needs to find out through the learning process with respect to how much data I am giving. So here, although for normal structures, as per the Indian Standard Code IS 1893 Part 1 2016, which we need to use, because the new recent November's Part 2025 is not allowed now after the recent rejection from the BIS. So the 0.05 is the standard one. So I varied from 0.3 to 0. Something, including that range, so that we can get that how the relationship between M, K, zeta, and C can be relatable to each other. Okay, and not only for Indian code, for American and ASC code or some other codes also, we get the same patterns with respect to the behavior of the structures on Earth or how it vibrates in the system. So here I just generated some synthetic data in my computer. In Excel, I have done that because I know the relationship, but the machine doesn't. So what I wanted to do is I wanted to feed it to the machine. Here, this time I've used the MATLAB. I cleared all the background things so it doesn't have anything. And after that, I wanted to feed these data with respect to that. So I have total 400 sets of data. Okay, because I just simply needed to run. Otherwise, everything I have. So I have done that. I in the loop or in the array I can also already create it in my MATLAB. But anyways, in Excel through Excel or through the generation in MATLAB, I can definitely invite these things in my system. Then we have X and Y, which is X, M, K, and zeta is the input, because normally we do not get the viscous damping coefficient because it is dependent on so many internal things as well. But the zeta is already recommended. So if we see the equation, so in the zeta we already know that that the damping ratio is dependent on the upper part numerator, which is the viscous damping coefficient, and the below part 2 root over km or 2 root over mk, that is the critical damping coefficient. So that is can be found to found. So obviously, if we feed m, k, and zeta, then obviously the viscous damping coefficient can be found. So with respect to that, I feed it 400 data, and this is how the histogram looks, and this is how the data looks. Obviously, in a very linear manner because the relationship is like that, and in a very small time step, in a very small step, I generated the data, not time step. Sorry. And here, this is how the linear data looks when I train it with respect to some algorithm. So this was basically a neural network model. So train ANN, this is the artificial neural network. And this is how, as there was so much data and the gap is proper, so for different use of neurons and for different other applications, I have got a pretty much straight line because the predicted data and the my own feeded data, those are pretty much the same. So it is dependent on the number of neurons that is used, and the system is optimized so that it can find out that how many neurons are used. If the terminology is neural networks and neurons, if it is already not known to some of you, then obviously in some of the few, examples today, we will be discussing that how a neural network works, and we'll be doing a more simpler problem from that. But this is just to show the example of how powerful a data set can be if it is proper, so that it can predict models, so that you can get pretty much accurate line for this type of linear relationship. Okay, so these are some of the layer plots that I tried to plot, and obviously we got pretty much good results. So next we will be understanding some of the concept like decision tree. Maybe some we know the decision tree, but here basically when we use decision tree as a machine learning model, then obviously this obviously creates some specific rule like a branches, like it goes like a branches with respect to how you want to grow the tree. There are different attributes how we can customize it, and it will be taking decisions to see, it will creating its own rule to check whether it is predicting the correct input or not. That is how it creates some rule, and it learns that rule so that it can predict something new. So just to know that, I introduced some new examples. So, but pretty much this is how the rule works. It works with different type of rules, like a tree with different branches, and this type of algorithm, this type of tree is developed by the system. So we can use the decision tree algorithms for different applications, so that where it is useful, so that it can predict things for us with respect to its own rules. And here, for my example, I have taken one of the geotechnical parameters. Okay, some very basic soil example for which the data is already known to us. So this is how it creates the rule. So let's say I'm taking a soil sample, and I have the void ratio and relative density. I mean, from the void ratio, I can find out relative density from a known expression. and by that the soil type, like whether it is loose, whether it is very loose, whether it is dense, whether it is very dense, and whether it is medium. So those ranges can are already known to us. So I just wanted to create some of those some of the predictions. I wanted to explore some of the predictions from the decision tree model in the machine learning tool. So I had some data like this, where I had initially I started with some data, and I already told the machine that this is the relationship, so that it finds the actual answer, that with respect to the standard rule, what is it. So if the relative density is between 15 to 35, it is a very loose soil, and we know these tables. These are already very known geotechnical soil mechanics application domain. We already know these things. So with respect to that, I told the machine to derive it. So what is actually should be there. So with respect to the known relationship, this is how. Here you can see that the relative density is 49.9986%. And here the new soil is medium with respect to this, with respect to what I put input, because it is finding with respect to the inputs, it found that it is between 35 to, sorry, it found it 35 to 65% of relative density. So it is medium. Obviously, these relationships are so much available for any domain. So I use this example. And after that, I told the machine just to understand the data set, not without understanding the relationship, so that it predicts only based on the data set it has. And then I compared both just to see how much error it is giving. Okay. So obviously, because there is specific range, if you do not tell the machine the range, then can it predict the actual result? Because it doesn't know the range. Let's say it is getting 64 point something and it doesn't know the rule, then how it can predict? So this purposefully I have taken just to check the effectiveness or the efficiency of these models. May not be necessary for these applications because we already know the relationship, but it is just to check the model. So initially I started with total 50 data set. Okay, 50 is the data set I have started just to see how it behaves, where I had two samples of very loose soil, 14 of loose, medium 16 samples, dense 14 samples, and very dense soil 4 samples, total 50. And here I have this in my computer. So from that, if I again use pandas like we did in the those plot example, I can simply get the contents from my Excel sheet to my system. So in my system, my plot is present now. Now here you can see I have introduced from sklearn the classifier, that is the decision tree classifier. Okay, and for exploring I have used that so that it can it can fetch it from the train model of the decision tree. So starting from it, here I have some things like the maximum depth we are using. That it is you can initially, if you are new to this, you can initially relate it with respect to how you are getting the roots go inside the ground. With respect to that, the tree grows, and with respect to that, the type of algorithm it develops to check the new rules. And with respect to rules, the more rules and more sophistication it gets, it actually predicts a better results, maybe for certain case where it is data based basically. And we have the random state based on how it will be exploring the branches. There are other more sophisticated and technically more accurate definitions of these, but this is how we can have the impression to start the modeling, start these type of model. So basically we have the E max, maximum void ratio, E min, minimum void ratio, that is the as E for the sample with respect to how we got the void ratio, and this with respect to that Y is the soil type. So I told it to take just the Emax, E and E min value from my Excel, and I told the soil type so that it learns, and with respect to the depth unit of 4 and random state unit of 42, it tries to develop its, it tries to explore its branches so that it can it can create the tree, and from the decision tree, it can give me some prediction. So let's see how it gave, how it went with 50 the data set that I had. So obviously it basically knew the inputs, and with respect to that, I told that in the export text like model, if I put these inputs for you, then just give me the output. Then what do you think about it? So it made this tree. It made this tree with respect to what inputs I have given, and now how I have customized the different attributes of the decision tree system. So it created the rules, and with respect to that, it was ready for the prediction. And I told it to predict for the maximum void ratio 0.6, the void ratio as 0.45, and the minimum one as 0.30. And it runs also this specific relationship just to see the accurate one, so that I can see the so see how much variation it is getting. So with respect to the known relationship, I told it to predict. No, I told it to not to predict, but to define, to calculate that what category it is, this soil is. And also I told it to take it from the machine learning tools from the decision tree, and to check whether it is predicting the accurate one or not, because from the known expression we know that is how the system is trained. uh, so with respect to the limitations, I was obviously a little bit skeptical, because it doesn't know the limitations, it just has some data. But in the analytical method, it has the direct relationship with the specific ranges. So this is the density index, and this is my soil sample, how it relies. In the x-axis, we have the sample numbers, and in the y-axis, we have the density index. So we have pretty much variations, as we know. So with respect to that, this is the variation, and we know that these are my 50 samples, and this is how it is distributed. These are the ranges, which we know as our known ranges. So basically, if you see, these are 1, 2, 3, 4, 5, total 10 examples. And here, when I have seen it, here the first example you can see the machine learning from the decision tree, the machine learning prediction was very loose. And by known expression, it was also very loose. So it is correct. The second one is also correct. The third one is also correct. Fourth one you can see is wrong, right? Actually, it should be dense, but it is telling medium. Obviously, because it doesn't know the ranges, but still it tried to predict. So from this specific analysis, we have got 7 correct predictions, and there are 3 wrong predictions. Obviously, it can be vice versa also, because I tried randomly for different type of soils. Obviously, it could do bad for some specific limiting ranges, but it tried to develop some algorithm. So now obviously the correct results are okay for this. I tried to explore the wrong results, that how much data if I feed, then it will be creating its own rules in the decision tree to take a good decision for the wrong sample, so that it is correct. Okay, because there are limiting ranges. So this is just to show you the application. So for the wrong data sets, for the wrong predictions, I went too far. And here this was the standard one. For the maximum depth 3 I have used, and random state 42 I have used. Now I increased it for the maximum of 5. So obviously the decision tree is bigger now. You can see the rules set that is bigger now, but still it is predicting wrong one. Then I have you increase the I let the root of the tree grow more, so the tree is much more bigger now, with the maximum depth 7. And then from this rule it is giving me the correct answer, but it doesn't mean that if I make it 70 then it will be again correct. Because obviously it is based on different data set which is randomly distributed. Okay, so anyways, so obviously as I increase the maximum depth, the tree grows bigger. As you can see, this is the rule making process is bigger, and obviously it looks like a tree, surprisingly. But anyways, obviously that is the decision tree, how it is making the rules, and it is making bigger as I am increasing the maximum depth. So this is bigger now as I'm giving inputs to grow it in my computer. So obviously these are the soil samples, but obviously we know that the data is something which is very sophisticated and very much important here. So what I wanted to do is I wanted to introduce, I introduced 100 more synthetic data to add with this very randomly in a very casual manner, just to see whether through those synthetic data of non-uniform distribution, it will behave properly or not. And I just kept in mind that in a specific type of soil category, there should be enough data. But that is not uniformly distributed, just to check that how the decision tree works. So obviously what I did is I just take these data, created some space for 150 data this time. And obviously I increased the data from 50 to 150 data sets this time. And obviously this time we have, obviously you can see for very loose, for very dense soil also, I have generated some synthetic data. so that from the known expression, these are within these ranges. So this is how it looks. It doesn't look so good because these are very casually generated, but it is within the range, but not uniformly distributed. So this is the specific range for the new data of 150 data set. And now when I introduce this in the initial training data set, then I got that it is a wrong result. Obviously, the actually it should be dense, but the machine learning prediction model is telling a very dense soil. So obviously, it's not a good prediction. It is a wrong prediction. Now what I did is the initial training data set size is increased. So maximum depth is decreased now. And now also again we see, okay, so now the initial data set size is not increased. It is also from the 50 data sets itself, sorry. But I decreased the maximum depth of the soil. Sorry, so not the soil, sorry, the tree, the decision tree. So from that, I again got wrong result. Now the actual should be dense, but for this input, the ML prediction is medium soil. So it is again wrong. And now I saw that, okay, so what I should do, I should keep the reduced depth, but I should keep the data set higher. So this time I've used 150 data sets, and the depth I have kept as same of the decision tree. And this time I got the correct result, which is the dense and the actual known expression also, it's a dense soil. So it is trying to figuring out the rules with respect to the data set and the depth of the tree that you are allowing. Also, there are other functions like random state, which we didn't need to use for these examples. So here we know that the initial, this is another example where for this example, what I have tried, this is another trial of that example actually, where the initial training data set size was kept and maximum depth is 4. And obviously we had a wrong result initially, we know. Now I have increased the depth of the tree, and this time it again I'm getting a wrong result. And this time I have again increased the same thing for this one, but the depth was also increased, unlike the last case, and this time again I'm getting the correct result. So there are so many factors how we can use the in the sophisticated models. Okay, so basically we need to remember there is a famous saying that essentially all models are wrong, but some are useful. So so that is what we do in the modeling part, because as engineering applications, as an application of an engineering tool or output, as an engineer we do model so that it does the work for us. It may not be 100% accurate, but it works for us. So for the machine learning also, it is more sophisticatedly applicable for more relevant manner, because here categorically we need to take it, we need to see all the variables and all the things to apply. Here we will see that for now the last stage, which is we will be primarily focusing in the example problems to continue exploring, and obviously we will be exploring some of the neural networks models as well. So that is one of the higher side of the machine learning tools, that is where we use neural networks. It is not so new, it is used for the normal applications, I mean, from decades. And we know that in the neural network, it is primarily the neurons in our head. There are billions of neurons how which interact to each other. So for some specific application, we artificially create in our computer, and then we call it artificial neural network, where obviously the neuron layers are there, and with respect to the actual neuron, how it works, it takes the input and sends to the next layer. We just explore the type of artificial neural network in our computer. So I tried very basic examples of artificial neural network. So this is for the prediction of normal stress. Everybody knows stress, obviously. So this is here what we have done is I imported some of the libraries to just to go for the artificial neural networks tool. And there are three segments. One is to inviting the tools. There are generation of data and the preparation of data so that our data is ready. So nothing here. Primarily, I created 5,000 data sets of stress. Okay, everyone can create, obviously, because we know the force, we know the area. Just give a force and area, and it will be creating. Then I need to reshape it in certain manner so that my system can behave properly. So I can reset it, and there is the first one is primarily the layers to for the keras, which is actually one of the efficient ANN tool in the Python. So in the model architecture, I have used it. Then I have used three layers of 32, 32, and 16 input. That is the hidden layer. Before that, I have one layer that is having inputs. Obviously, I have two inputs, that is the force and the area to get the stress. And we trained the model in through the neurons. So this 32 32 16 is the hidden layer. So here you can see that these neurons, these inputs are going to the neurons of the hidden layers, and the more you bring the hidden layers in the diagram, there is one hidden layer, but actually I have used three of it, which you can see. So it is the neurons are actually trying. The more neurons you put, the more now number of times, the more number of ways it analyze the data, and it doesn't analyze the same way every time. It analyze different ways. So every time we do not get same result. But with respect to the interpretation, it doesn't vary if you put the parameter, if you put the basic inputs correctly. So with respect to the hidden layers, it is trained, and in the output layer, it is giving me the final result, whether how it is behaving. So now we have checked that for the here for the test value of 450 units of force, that is Newton of force, and 18 meter square of the area, how much will be the stress? We can calculate it, and that's why here what is done. Here you can see that the predicted result and the actual stress, the predicted stress and actual stress is pretty much near. But you can get huge variation because it does some type of interpolation itself. So if the data is not proper, if it is not properly distributed, and if we are not using the layers effectively, and we are not using the correct model effectively, then it will again give you full bad results. We have limited time, so I showed you some of the good results now. But if we customize and if we work on it, we'll know that how to fit it for our known outputs, for our expected outputs. I simply change the same model just for a case of super elevation. We all know what super elevation is. So for super elevation of a road where the curve is there with respect to the velocity of the vehicle and with respect to the radius, we can find out if we know the F, that is the lateral friction, okay, the coefficient of lateral friction. So if we plot it, we know that these are type of relationships are there. How we can plot it with respect to the velocity versus super elevation, or the variation, how it works with what different type of velocity ranges, and we see it. So for this is not machine learning. Obviously, we are simply seeing different plots of the data, how the relationship looks, so that we can feed the relationship to the system for the known, analytical output, and also we can feed it. Uh, Also, we can train it with respect to some existing data so that it works the same. So same model I have used, just change the number of sample is still uh, same, that is 5,000 number of samples, but this time I have used the radius of in meters, 80 meters to 120 meters, just to create my data, and the velocity of the vehicle as 50 to 80 kilometer per hour, and the lateral friction I have kept fixed for this problem, which is 0.15. So with respect to that, I am telling it to predict the super elevation, and from this example I am actually checking whether it is correct or not. So first, to create it, I've created 5,000 data within these ranges. Once I have the data, again I have used the same layers actually for this problem, same settings in my artificial neural network architecture, and again the inputs layer, hidden layers, and output layers works, and with respect to that I get some specific output. And here I have seen that for this specific input of 90 and 65, that is 90 meter radius and 65 kilometer per hour vehicle, with the super elevation is 0. Like the actual one is 0.2196 something something, and we have some error here. But if we run it with respect to that, we will be, if the same code I run again, it will be giving me something else. But if the system is stable, if my model is stable, then pretty much it will be similar, it will be same. So here the error is acceptable for certain cases because of the round off that we do. So it depends on the type of scheme, type of problem, characterization of data, characteristics of layers, number of neurons. We have very limited time. We'll be just going through to explore some examples where it is hugely useful, and we get some research papers also. Like here, we model systems very often, and once we do that in different design softwares, there are applications of in generative design, topology optimization, rapid prototyping, where the machine learning algorithms are used. And there are obviously so many type of response reduction techniques that we do. There are automated damage detection, vibration analysis, digital twin where we use it. There are disaster resilience and safety domain where the size for the seismic analysis, in wind engineering, in fire safety, we can definitely see the applicability of machine learning techniques where the things are too much heavy, we can definitely check that. 1 second. Yeah, there are predictive maintenance. There are health monitoring domain. There are risk assessment where what we do, what is can be done from the machine learning domain using some advanced tools like drones. And there are some recent patent also from our university where on from our department, which is on the machine learning models on some NDT testing as well as the picture detection data. So there are so many work already going on. There are abacus and ANSYS type of softwares which analyze the material too much properly, too much sophisticatedly in detail with the finite element methods. And we have some smart materials nowadays which can be useful for different applications. There are different geotechnical engineering applications like subsurface characteristics, slope stability prediction, and so seismic hazard mapping and nonlinear soil modeling, etc., where things are complex and can be simplified from the machine learning tools to analyze different type of soil characteristics. So here you can see some of the AI enabled prediction by the scientists for the landslide, for understanding the landslide potential for the slopes. Now the transportation engineering domain also, there are intelligent traffic management, because we have cameras nowadays, we can see the traffic density in a different manner. There are more sophisticated tools to simplify the data so that when you are going to office it takes less time, or for applicable for any human. Now we there are for the intelligent traffic management, pavement and asset management, public transit optimization, travel demand modeling, and so on. We have navigation. Recently in Google Maps we have the Ask Map feature, which plans the thing for us by using AI. There in Vizag they have rolled out AI driven traffic management systems. uh, in environmental engineering, there are in water quality monitoring, water management control, and carbon footprint analysis, ecosystem monitoring. There are applications, obviously. There are automated machine learning, archives accurate water quality prediction with reduced parameter requirements. Is a research paper. There are so many. I've just introduced some of them. In bridge engineering, also similar structural health monitoring and generative bridge design models are applicable, which I have discussed for the structural engineering. In Bihar government, recently, after their huge failure within few days in September 2025, for IIT Delhi, they are collaborating with it, and they will be training their engineers for the AI-driven technologies on the bridge design and the bridge maintenance, etc. Similarly, for other core engineering applications also, we have so many applicability. Now if someone wants to start exploring, if so you are not too much into all these models, then how we do it with respect to that, I can just share my experience. So with respect to my understanding, there can be three possibilities. One is the explorer. Obviously these are my understanding how you can explore things gradually from simple problems. There are the developer. From the scratch you can develop many things, but in many places what happens, we do not get the time for, because we have different so many other activities and domain to explore, because we are civil engineers or core engineers. So sometimes we use the tools and become the practitioner to for using some subject expert tools, because it is already developed by the data science engineers and the data scientists and the computer science people. So as it is a huge world, we have so many things already there. So as a practitioner, we can use those tools to start exploring it. Okay, or you can just simply wipe out those boundaries and make our team like this, so that all work together and different expertise can be invited to solve a significant problem that will be helping us solving it, like what I try to do and my team tries to do. So obviously these understanding exploration won't be possible, could not be possible if I didn't get the things from my students primarily. So there is a small team at Kolkata in Jadavpur University, where we try to explore some of these things in some of the existing problems. Okay, so this is one of my one of my the team which is close to my heart, which is the VibCon vibration control. And here we what we have is we have so many existing problems already, and we try to solve it, because earthquake engineering is a challenging field where obviously the predictions are unpredictable. I mean, predictions are necessary for certain cases. We do not know which type of earthquake and what type of behavior will be there on the structure that we will be designing, and there are obviously other sophisticated aspects like all the fields we all work for. Like we start with very basic numerical model. Okay, so we start with very basic. Okay, it is stucking for some reason. Very basic numerical models we start with. This is a very small team I have. This is the current team actually. Okay, there are more applications, but these are they have reached certain levels, that is level 3 and level 4. That's why I included their pictures. So they are primarily students and of our institutes of different levels. So we start from level 1, 2, 3, 4, 5, and we start with basic problems. And for that, to participate, for the existing students, unless it is they are allotted in some major project or something, generally we receive the I receive the application with respect to something called Learning Connect platform. So I won't explore much, but I will just show you. Here also I tried to use some data science type of parameters where student participate everything every day for 10 minutes in my class, which only they can participate when they are in the class. And with respect to that, the data science, with respect to this very simple data science applications, I have automated some systems how they can get specific insights of their performance, daily performance, overall performance, and with respect to the mentorship. Obviously, with respect to the class performance, they get rewards, and there are certain segments with respect to the mentorship part as well, which is automated. So with respect to this score, I allow them. Okay, this is just to mention because it is a uh, lecture on machine learning. We start with level 1 for basic problems, then we optimize it, we do it more specific to the engineering applications, real life engineering applications. Then we go for some, when it is already ready and we get some novelty from that, then from level 2 to level 4 we go for the outreach and communication stage. And then the level 5 is for invention, which is very rare. So with respect to these stages, you can see that all these stars are already the level 4 attributes in the last 1 year, where people have uh, claimed. I'm sure that in the future, few months also, we'll be getting few things to show some recognition of these students and their hard work, how what they do. So these are some of the pictures of the recent conferences where they have got. They were there in some international conferences. One of our vibration control papers also got the best paper award. And now some AI enabled things are going on these models in the some of the upcoming book chapters and conferences. Maybe we are actually planning that maybe within this year some positive news will become. This is some of the contributory presentation from my team. So first we simply simulate from different known things. We simply use the known numerical techniques, numerical analytical methods to analyze the system, and then we try to use some machine learning models sometimes to understand the system. Like this, you everybody knows this is a pre-vibration for the first one for a single degree of freedom system. Second one is the harmonic excitation. Third one is the base excitation, how the system behaves. So that in the upper side you can see the responses. Here this same thing goes on for the multiple vibration, multiple degree of freedom system for multi-story building, chimneys, or for huge structures also it is applicable. So it is a just some simple plot. This is actually this animator is developed by our team. Basically, I have done that, and I call it arraymation. It simply converts the array to animation. Okay, it's a very simple code, and there also I have used AI to write it. Okay, because that is not the engineering, civil engineering part of it. It's just the plot, just to see how our system behaves. So with respect to that, after the system is satisfied and we do the necessary validation, then this is one of the project of my student who have used the graph neural network assisted genetic algorithm, just to use the machine learning technique and to optimize it by certain steps to and to predict to see whether the dynamic response, which is itself so much unpredictable for the general cases with respect to earthquake, whether the machine can predict it correctly to understand its pattern or not. So after several trials, after the basic validation is done, here is the results where we have got pretty much good results actually. Here you can see that from the red line the results are not too far, but some results are too far. It was problematic, but it was still sorted out. We are so they are still working on it, and we got some good results after the optimization. And with respect to following the specific work plan, including the machine learning algorithms into the dynamic systems, we also got one of the recent papers of my students. So as a conclusion, we can say that here the precision point of view, there are different results, but we know that all models are like that, with respect to which we as an engineer are the regulating person who will be deciding that which is applicable and which is not. So those are very powerful tools. There are the domain of rapid innovation nowadays, and there are proactive reliability with respect to different type of shifts and paradigm shifts we are facing with respect to these machine learning tools nowadays. And to start exploring, we can actually go through different models, different domains, and different tools. And if we explore, we find out that which will be the correct setup, correct setting for our own application of whatever domain we are working. So to carry the tools and to exploring is one of the possibility which may give us some beautiful findings to explore it more. These are some of my the main references that I have used for this presentation. And thank you so much for being patient. The time is there. Okay, I have finished, and please let me know if there is some questions for the interaction. I'll be happy to hear and interact. Thank you so much.
Thank you, Professor Borua, for an excellent presentation. You really explain step by step the process and the application of machine learning in
Thank you
civil
so much.
engineering. It's really great. So, thank you so much, sir. And
Thank you so much, sir, for giving me this opportunity to connect. And if the audiences interact and they have some questions, I'd be
yes,
more
yes,
delighted to enrich also.
yes, yes, yes,
And
yes, yes.
thank you so much for the opportunity.
Okay, it's our pleasure. Now, I like to invite Mr. Soikat Krishna Paja, Assistant Professor of Civil Engineering Department in Holdia Institute of Technology. Mr. Paja will now moderate the question answer and also the proceed by the vote of thanks. The participant, please share your questions in chat box. Soikat, please unmute.
Thank you. Participants may share their questions in the chat box, or you may turn on your microphone and ask directly.
Sir, I
Sir, the
think there are
first
some
question,
questions are there in the chat box.
sir, the first question
Okay.
is from Mr. Kaushik Bera. The question is, can we extend the curve in slide 92 in the graph?
Okay. Let me share it so that I can see which one is slide 92. Okay. Okay. Slide 92. Okay. Almost there. Slide 92. 92 is this one. Yeah, yeah. Yes, yeah, we can extend the graph if we have more data. Here, purposefully, I have taken less data to just to show the behavior. But obviously, the more data we feed, the more graph we have. Here, as we can see, we had very less data initially. Okay, so that's why there is only 10 data set. So that's why this is the small graph. If we feed more data, it will be generating more.
Okay, sir. The next question from Mr. Bera. When rating is same, which one
Yes.
we can choose and what is the basis?
Okay, the rating, right? Okay, right. And that is in the multivariable one, I remember. Yes, yes. So here, basically, what happened? Obviously, the plot of a price, sorry, the price of the plot is dependent on many things. I cannot take all the factors here in this example. That I have. That's why I have introduced the rating. Like in different products we buy from the internet in different places, for different places. Maybe the for rating 5, we have a perfect position uh, from different functionalities. Maybe the hospital is nearer, maybe the plot is just aside the road, the main road, maybe the transportation is more suitable. So based on that, it is predicted there. So now how the system predicts, it just sees that with respect to the area and with respect to the rating which is given out of 5, it sees the maximum and minimum rating first. So here the minimum is 2, the maximum is 5. So the system learns that when with respect to the proportion, when the rating is higher, then the price is going higher for the examples, for the data it has. So that's why it is predicting that if the rating variable is going higher, that means it has some influence in the price. Then it analyzes all the data as a multiple variable, and it understands some relationship, so that if some rating is put by the user, then from the medium, like 2.5 is, I mean, 0 to 5 by 2 is 2.5. So if it is more than 2.5, it shows in what rate from the given data if the price is varying. With respect to that, it decides the function and it assigns to the output so that it gives higher rating. Now if I manipulate this data, and if for higher rating I give it bad data, that is the data of a lower price, then it will think that if the rating is higher, then the price is lower. So it is, with the feeded data, it is trying to analyze the data in a certain way, so that it understands that how is it affecting. The machine learning algorithm is written that way. So the more correct data, more relevant data we feed, and the more number of data we feed, it the machine understands the application of any variable like rating more sophisticatedly to the machine learning algorithm. So that is it. That is how it learns.
Sir, we have one more
Totally.
question.
Yes, please.
We have one more question from Dr. Ravi Sarkar, and that is, what are your thoughts on vibe coding and the way agentic AI is exploding?
One second. Okay. Yeah, agentic AI are exploring. Initially, when agentic AI started, then it initially gave really good, I mean surprising results. After that, when it got more data from internet, then obviously it is behaving in a different manner. One time I was using it, I mean, I think 1 year back or 1.5 year back, it was really bad responses. I was not satisfied with the way it was behaving. Now also it has recovered, but it is not that good. But the thing is, I with respect to how humans, that is, as it is learning from the data set which are created, generated, or collected by humans, so its behavior is also becoming the same, the way the basic core algorithm is there. So when we use these type of agents, then with respect to specific application we should use, also for all agents there are some customization option, where if we go and if we put some specific inputs with respect to how we want it, then it gives us more better results. And every time we need to validate it. For nowadays, I mean, there are certain AIs nowadays who are giving the reference list from where it is giving you the result. But in many cases, some of the very direct codes that it is writing, or the some very direct result that it is giving, is totally wrong sometimes. So we need to validate those things in order to interact with the agentic AI. But obviously it is just very new. We are very new with the new generation agentic AI. Agentic AI was there many years back, but nowadays the machine learning flexibility it is having, that is not yet totally stable. I think within few years it will be giving you more sophisticated. It will be giving us more better answers with better search engines, etc. And many people are working on that. There is Perplexity and Liner also, who are uh, trying to understand in a very other sophisticated way. Okay, so that is my understanding on that.
Thank you, sir. With this, we come to the end of question answer session. Myself, Soikat Paja, on behalf of the entire organizing team and the participants, extend our sincere gratitude to Professor Indrajit Barua for this excellent and informative session. Your expertise combined with your thoughtful engagement with participants has made this an outstanding contribution to the FDP. Thank you, sir, and also to all the participants for
Thank you so
continuing
much.
to engage so actively on day 4. Your dedication is just awesome. Session 1 of day 4 is now concluded. We look forward to session 2 in this evening. Thank you.
Thank you so much.
Good evening. Am I audible?
Yes, sir, you are audible.
Okay, thank you, sir. Good evening, participants. I am Abhishek Nashkar, Assistant Professor, Civil Engineering Department, Haldia Institute of Technology. It is my pleasure to introduce our speaker for this session, a practicing hydraulic engineer whose work is directly shaping how we manage water in our cities and river basins. We warmly welcome Dr. Shayok Nandi, hydraulic engineer at Haskoning India Consulting Private Limited, the Indian arm of Royal Haskoning DHB, a globally recognized independent engineering and consultancy firm with over 135 years of expertise in water, maritime, infrastructure, and environmental solutions. Dr. Nandi holds a PhD in civil engineering from Jadavpur University, 2024, where his doctoral research focused on the morphodynamic behavior of the river Damodar under the combined influence of dam discharge and barrage operation, a highly complex and practically significant study for the river basin management in eastern India. He also holds an MTech in geoinformatics from IISc Shibpur and a BTech in civil engineering from West Bengal University of Technology. His expertise spans hydrological and hydraulic modeling, urban drainage design, river basin modeling, sediment transport, barrage operation modeling, geoinformatics, and bathymetric surveys. He is proficient in industry standard software, including DHI MIKE, SWARE GEM, SWMM, ArcGIS, HEC RAS, and HEC HMS. Dr. Nandi has a rich and varied career as a research scholar at Jadavpur University, a district GIS expert with NGN REGA cell under the government of West Bengal, a guest faculty at Jadavpur University, and a freelance hydraulic modeler for the River Research Institute, government of West Bengal. He has also published in reputed journals, including the ISH Journal of Hydraulic Engineering, and has presented at international conferences, including River Flow 2020 at Delft University in the Netherlands. In his current role at Haskoning India, Dr. Nandi is the hydraulic engineer on the prestigious project preparation of GIS-based compressive drainage master plan at DPR for Barakpur subdivision and Bidhannagar Municipal Corporation, India, North 24 Parganas, West Bengal, commissioned by the Kolkata Metropolitan Development Authority, covering 400 square kilometers. We are truly fortunate to have him with us in this evening. Please join me in giving a warm welcome to Dr. Shayok Nandi. I would also like to welcome my co-host, Mr. Shoikat Chom, who will be helping to lead today's discussion. Dr. Nandi, the podium is yours.
Thank you, sir. Uh, Welcome, everyone. Uh, as Abhishek sir said, I am working as a hydraulic engineer, and I am going to present some of my works that is directly project related and industry related. How we deal with our practical problems related to water logging or water basin management. So, shall we start, sir? Yeah. So I am
Please
presenting.
start.
Yeah. Is this visible? My presentation?
Yes, visible.
Yeah. So we are going to
Yes,
discuss.
sir, visible.
Yeah, thank you. So we are going to discuss about this project, which is related to preparation of drainage master plan and DPR of Barakpur subdivision and Bidhannagar Municipal Corporation area. In this project, we Haskoning are working as a consultant of KMDA, whether we are going to prepare master plan and as well as detailed project report. Uh, so the objective is to mitigate the water logging issues throughout these areas. So before that, I would like to give a brief introduction about our company. This is Royal Haskoning DHV. As sir said, it is spread over 140 countries and like that, and it is one of the leading company which works in the domain of water. So these are the projects which are we are doing right now throughout India. All these projects are mainly related with river basin management, flood management, bank protection, and stormwater drainage management. So a brief introduction about our area. This is mostly Barakpur subdivision. Under this subdivision, there are 16 numbers of municipalities and 2 numbers of blocks, which is under Panchayat area. And another one is Vidhannagar Municipal Corporation, which geographical area is around 60.5 square kilometer, and it is located, we all know, in the Salt Lake Basin. So in this study area, there are 2 major rivers flowing across the study area. The left boundary is marked by Hooghly River, which is the left boundary of this study area, and in the right portion, there is Vidhadari River. So this study area is uh, is a part of these 2 subcatchment of these 2 river basins. Now, water logging throughout this area is a persistent issue, as this section is mostly low lying areas, and often gravity flow is restricted due to not having proper slope. So along throughout this area, a numbers of canals are also flowing through. The storm water, which we are dealing with, the management of storm water, mostly passes by canals. We deal with the modeling of canals and the drains that deposits in the canals. So the objective of this project is, firstly, is to prepare a GIS database where all the essential details about the study area, like drain network, canal network, drain catch basin details, and road network, railway network, all these are captured and prepared as GIS database and presented as a base map, which works as a fundamental foundation of our work. So mostly the objective uh, is to provide short-term, mid-term, and long-term proposals through which we can mitigate waterlogging issues, and is in mostly in a sustainable and nature-based way. So these are some guidelines which we follow, that to provide a drainage system which can manage the precipitation and flooding in the vulnerable areas, in the low-lying areas. This means to check the carrying capacity of the present drainage network and to propose new network if needed. So this is a technical part of checking the capacity and proposing or designing new drains, which we'll discuss in later course. And another is improving surface storage potential and lower surface runoff. So another objective of this project is to reducing the surface runoff. Rapid urbanization has rapidly increased the surface runoff in this area, which is one of the major issue of water logging in this area. So we use solutions like retention pond, like that, and greeneries to reduce the surface runoff and to increase the base flow of this basin. And like all this, and providing pumping stations, or else if there are any other alternatives other than pumping stations. These are the infrastructural proposals which we are going to propose in this project. So as we have gone through this project, we identified that there are major problems which we need to deal with. This is that the topography of this area is mostly low. It's a low-lying area where gravity flow is restricted, and another is there is mixed flow. All this area is suffered from mixed flow. Mixed flow means the stormwater drain is mixed with the sewer water. Almost all sewer water comes in the stormwater drain, as there is no separate sewerage system in most of the areas, which increases the total runoff of a catchment when the sewerage water comes, and often the carrying capacity of the drains uh, cross, and there is water logging. This is, we identified that this is one of the major issues of water logging in this area. Now, again, all these drainage structures which we are dealing with was designed 70 or 80 years ago, where rainfall pattern was much different from now. So right now the rainfall is much higher, and all these drains are designed with a rainfall data which is of 72 or 80 years ago. So also we have seen that in many sections there are no proper drainage system, and disposal of solid waste silt. This has drastically reduced the storage capacity of the drainage system. So now what we have done, that the first part was to identification of data and preparation of base map. So for preparation of base map, we have gone through detailed survey. One is a physical survey where we have marked all the drainage systems, uh, physically visiting them. And after that, we have gone through topographic survey where we have collected level data uh, with an interval of 25-meter or 50-meter as needed. These are both for roads, drains, and canals, as well as part of Hooghly and Vidadari river. Also, we have gone through CCTV survey. CCTV survey is a survey which is done for the underground network, where we have moved our CCTV, and through the video we have checked where if there is any leakage or broken drain sections like that. And there are multiple pumping stations throughout the area, almost 130 pumping stations. We have visited the pumping stations and quantified them, their capacity and how they are working. And after that, we have also collected data of outfall points, the drains that are outfalling in the canals, and as well as the canals are outfalling in the river. We have marked the outfall points, as the outfall points of these basins plays a major role of managing stormwater. We also have checked water quality of the canals in the outfall points when it is depositing in the river, because as per the manual, as there are certain limits of each of the parameters. The parameters should be, the pollution level should be below that before depositing in the river. So at first we have gathered the basic layers like road, railway, built up area, all this layer, and we have prepared a base map for each and every municipalities in a GIS platform. So now after preparing the base map, we have gone through identification and the assessment of the conditions of the drains. I would like to show the some of the data. This is a sheet, I think it is visible, where we have gone through each and every road, where as you can see the street name is mentioned here, their northing, easting is mentioned here. After that, their width is mentioned, and their working conditions, like how they're working, what is their material, and what are the road type of roads and the width of roads. For throughout these sections, we have prepared this, which will work as a database for our future modeling. So here we can see that the some photos of physical verification of outfall points, where we have all systematically mapped the outfalls. Here is a condition assessment sheet of outfall. As we can see in every photos, the some drain is outfalling in some canal. We have marked the outfalls, and we have seen their depth and their conditions, like if they are silted, if there is any solid waste dumping, if there is any encroachment, and how is the condition of the embankment. Now, we have also gone through uh, condition assessment of the pumping stations. We have identified the components of a pumping station. We have done this for 112 drainage pumping stations throughout the area, where we have identified the components of a pumping stations and how they are working. We have also gone through NDT test of the pumping stations. This is for how assessment of the structure of the pumping station, which is not part of our hydraulic study, but just to say that the NDT test is also a part of structural assessment of pumping houses. Now, how a condition assessment sheet looks like, you can see that for a certain municipality, We have marked the canals that are going through the municipality. In Titagarh municipality, we can see that there are 4 canals going through the municipality, and their condition also have assessed that they are silted and there are encroachment in certain portions, and there are solid waste dumping. And there are pumping stations. We have visited the pumping stations which are currently working, uh, and we have assessed their conditions, and we have gone through the survey of the total area for our future modeling. This is some of the photos you can see of CCTV survey. CCTV survey has done for the underground manholes, where we have seen that most of the manholes here are broken and there are leakage. And we have identified the shape and size of the pipes, which cannot be done through surface survey, as we can say, through uh, total station or DGPS. This some report of water quality test. We have collected samples throughout the rivers and canals and identified, we have fixed some parameters like BOD, COD, as we all know, TDS, and nitrogen, nitrate, ammonia, all this. And as per CPHU, there are certain limit that the discharging canals, these parameters must be must be below this limit. So wherever the limits are exceeding, we are proposing for a sewage treatment plant at that outfall points. So this is another part, is water quality test. This is some of the photos of survey work have gone through different roads and drainages. And these are photographs of canal survey. We have used ADCP, Doppler method, as I think all know how ADCP collects data, cross-sectional data of canals, and bank data, as well as water level data. We have captured that. Now, after that, the previous part was about data collection. We have collected data throughout all the infrastructural components of the study area. And after that, next part is to design using this data. So for designing, we have we've brought uh, rainfall data from IMD, Indian Meteorological Department, Pune, for last 30 years, and we have prepared a IDF curve, intensity duration frequency curve, and I am showing IDF curve for 2-year return period, and for different duration we can see the different rainfall intensity. So mostly what we're doing in this study is we're taking a duration of 1 year and a return period of 1 hour and a return period of 2 year to identify the rainfall intensity. As we can see that mostly the rainfall intensity is around 60 per hour. For capacity check of the present drains or for designing new drains, we have took this data as a rainfall intensity of the major drains. For canals, we have used return period of 5 years, where rainfall intensity got much higher. Now, for designing, these are the parameters we have, which we have considered. First is rainfall data, as we have discussed. Next is the return period. The return period, we all know that different structures we take different return periods. As for dams, we take return period of 100 years. For drains, we took return period of 2 year, and we have prepared a IDF curve. And we also considered a climate change factor, because analyzing the trend of the rainfall pattern of last 30 years, it has been checked that it is increasing as a 15-year in decade, 15% in decade. So we considered a 15% increase in in rainfall intensity. Now, for discharge calculation, we use the rational method, where the discharge is calculated is considered as a function of CIA. C is the runoff coefficient, which depends upon the land use, land cover. I think we know that the C is the ratio of how much water is penetrating and how what the surface runoff is generating from a rainfall. But I is the intensity, and A is the area. Area is the catchment area. So for each and every drain, we have delineated a catchment area. Catchment area means the area from where rainfall is, water is contributing in that drain. That is considered as the rainfall, as the catchment area. Now, for designing of a new drain or for checking the capacity of a drain, we consider the traditional Manning's formula, which is V is equal to, which is the parameter of slope and width and depth, the capacity, you may say. Now, for C, we took the land use land cover map from KMDA, and we, for each subcatchment area, we assigned a C value. We know that there is a C value already mentioned by CPHU. For having more urbanized area, the C value goes much higher to 1, and for the rural area, the C value is close to 0. As in the urban area, there is more surface runoff, and in the rural area, uh, there is more base flow. Now, there are also some uh, some some rules about providing minimum cross section of a drain, which is at least the drain should be 300 millimeter wide. Now, there is another parameter, which is time of concentration. We took time of concentration. We considered time of concentration uh, to to calculate the duration of rainfall. So, time of concentration is basically when the peak flow happens in a catchment area. Now, as I can't show all the municipalities, what I thought that I will show analysis of a certain municipality, which is Titagarh municipality, and that what are our analysis, what we designed, and what we proposed. So, as a sample, you can say. So, this is Titagarh municipality. You can see the map marked in red. There is a square kilometer, 3.3 square kilometer area, and having a drainage structure, drainage network, I think around 60 kilometers. So in Titagarh municipality, all the storm water goes towards Hooghly River through 4 khals. We will see the canal map of Titagarh municipality in the next slide. This is the contour map which we provided, which we developed through our topographic survey. Now, this is land use land cover map, uh, where you can see there are mostly, this is around 40% there is residential area having a high C value, and after that there is industrial areas in the beside the Hooghly bank, jute mills and all that. So around 35% of the total area is industrial area here. So this is the canal map of Titagarh municipality as well as the drainage map. Here you can see that in the upper boundary of Titagarh there is Kelvin Khal. I think it is visible. What we have marked the outfall points. This red dots are the outfall points where the primary drains are outfalling in this canal, and the green points are the outfall points of canals in Hooghly River. So we have marked all the canals, drainage, as well as the outfall points. If you can see, in beside the outfall points, there are given some data. First, the name of outfall points. Then there is canal invert level, drain invert level, ground level, and full supply level of the canal. So there is a analysis of how much primary drains are there, how much secondary drains are there, and how much tertiary drains are there. So altogether, there is 64 kilometer of total drain length, 58 kilometer of drain length. We are having total road length of 6 kilometer. This is because around 6 kilometer of area in Titagarh, 6 kilometer of road in Titagarh is uncovered, having no dedicated stormwater drainage network. So we have marked the hotspots of the Titagarh. This is used while calibrating the model. We have simulated the Titagarh drainage system in a SWARE-GEM model, where we have given the input of this network data as well as rainfall data, C value, and all that, and we have seen where water logging is showing in the model. So these hotspot areas are the factors through which we have calibrated our model. Now, after simulation of the model, it is observed that around 9 kilometer of the total area, 9 kilometer of the total network is undersized. Most of the water logging is happening here because most of the drains are undersized, not having proper carrying capacity. While the peak rainfall occurs, this water cannot be passed through this drain. So we have marked the road where revamping or resectioning of the drains are required. So identification of the drains which needs to be resectioned is the criteria is if it is overflowing, as well as there is another factor of velocity. If the velocity of water does not lie between the range of zero point 0.6 to 3 meter per second, then it is to be considered that the drain is not appropriate and we need resectioning. This is because when the velocity is less than zero point 0.6, there is a high chance of siltation, and when the velocity is more than 3 meter per second, the drain may erode. So at first, as you can see, we ran our model for a rainfall intensity regarding 20 millimeter per hour for a sample check. After that, we simulated our model for a 2-year return period having rainfall intensity of around 60 millimeter per hour, where it is shown that a much higher length of drain needs to be resectioned. It is almost 21 kilometer out of 58 kilometer. So we have marked the drains where resectioning are needed. This is marked in this image with red colors, you can see, and it is written in the legend that these are the flooded drains. So we are proposing resectioning of the drains, and in many points there are not proper slope. So we are also proposing there should be proper slope having a proper outfall in secondary or primary drain. So after that, we have done backflow analysis of each and every outfall points. We have seen that we have marked the outfall points. Here backflow plays a major role in the water logging of area, because while high tide, the water level of Hooghly River increases and the water comes through the canals which are depositing in Hooghly River. So at that point, when the water level of Hooghly rises, the water level of canal rises, and there is a stagnation of water, and that is the major reason of water logging in this study area. So you can see that we have analyzed the IL and GL of each drain as well as the IL and GL of canals. We have also, you can see the full supply level of canals. We have checked, and the discharge that drain is carrying, which we got throughout our model simulation, that is also given here. So now, as you can see, that for a certain outfall point, we have marked them that if there is any backflow happening or not. So we have marked there is along 6 or 7 outfall points where backflow is happening, where water is moving in opposite direction. So at these points, intervention is needed. We have suggested gates, sluice gate or flap gates, as well as pumping stations in these points to prevent backflow. After that, we have also checked that if there is any scope of proposing new drains in this study area, and we have seen that around 18.3 kilometer of new drains must be constructed in this study area to cover all the study area. Otherwise, a portion of the study area is left uncovered, where water logged and it flows as a surface flow. There is no drainage system for flowing of water. So we have marked them, that is around 18.3. So this is a detailed table of how much we need to resectioning and what will be the proposed width, proposed carrying capacity where resectioning is needed. This is a basic summary. So apart from that, throughout field verification, we have seen that there are other multiple issues. That is, you can see that most of the drains are heavily solid waste dumping, is going through heavily solid waste dumping. Their carrying capacity has reduced up to a certain limit due to this solid waste dumping. There is encroachment throughout the drains, and there is a reverse slope. There is a reverse slope, you can see, where the water is flowing through another direction and the road is going through another direction, where the water, there is a chance of clogging of drains in these cases. So now for a holistic approach for providing recommendations, we considered 5 parameters, that if a catchment area have hotspots, uh, the ratio of hotspots, if the hotspots is less than 20% of a catchment area, we consider them as at this area is at very low risk. And if the catchment area is fully waterlogging, then we consider them that it is in very high risk. Next, next parameter is the uncovered area. In the uncovered area, we have also gone through the same analysis, that how much uncovered area is there within a catchment. If there is 100% uncovered area, we have considered them that this catchment is in high risk and intervention is needed. After that, we checked the quantum of major khal and drain of different catchment areas and classified again in the same way. Next is backflow magnitude. We have marked the outfall points and we have calculated the magnitude of backflow in different catchments. And this is one of the parameters. And after that, the next parameter is critical infrastructure. If there is critical infrastructure within a catchment area, we have given them extra weightage for these areas must be protected and there must be no water logging. So you can see Titagar has been classified in 6 catchment areas. For each catchment area, we have categorized them and marked them with a value, and we rank them that which catchment must be intervened at first. You can see that here the catchment 4 is the highest ranking one, the first ranking one, where intervention is needed in an immediate order. So what are the interventions we proposed here is given. First one is the backflow management. In the catchment 4, which we are talking about, there is a major outfall point, and the water from Hooghly River comes in the Enespat Khal. There is an Enespat Khal which goes in Hooghly River through this catchment, and when in the time of peak rainfall, the water level of Hooghly River rises and it causes backflow. So we are proposing gates and as well as pumping stations in the outfall point, so that this backflow can be prevented. After that, the next intervention is hydraulic capacity recovery. Hydraulic capacity must be recovered for the certain sections where the carrying capacity is not sufficient. As well as these canals must be desilted and the encroachment must be removed. A major part of these sections is needed with repairing and desiltation. They are broken, and we have proposed that there must be repairing and desiltation program must be taken up. So in this way, we have proposed measures for each and every subcatchment. Mostly they are classified as preventing backflow and designing new drains and repairing of the old drains. So mostly this is the approach that we work on. So thank you. I would like to have any questions if there is any.
Hello, everyone. This is Soikat Som, Assistant Professor in the Department of Civil Engineering. I would like to thank Dr. Nondi for such a comprehensive and practical grounded talk. This presentation, I think, is very much practical grounded of our real life problem. And whatever I have seen in this presentation, this type of practical problem we used to teach our students regarding this kind of design and all these coefficients. What are the different types of rainfall criteria we need, and different water testing processes we used to teach our students. So this is very helpful for us also, as we have seen very good, comprehensive and practical kind of work from you, sir. So right now, I want to say that if anyone have any questions regarding your presentation, you may ask in the chat box, or you may open your video and you can ask to the Dr. Nondi sir directly if you have anything. So actually, sir, no one has asked any questions till now. So
Yeah,
I-
anyone can ask me also later if some question arises. I will
Yes,
be very
yes,
happy
yes.
to discuss again.
Yes, sir. Yes, sir. So actually, the thing is, so I want to say that I myself, Soikat Som, I want to extend my warmest thanks to Dr. Shayak Nondi sir for your excellent session. Your contribution to this FDP has been invaluable. As we approach to the final day of this program, it is gratifying to see the high level of enthusiasm and intellectual engagements that all participants have sustained throughout. We also thank our convener, Dr. Abir Sarkar sir, and the full organizing team for their tireless efforts in making this program success. And session 2 of day 4 is now closed, and we look forward to see you all of you for the final day tomorrow, and want to thank everyone, including Dr. Shayak Mundi sir, for your
Thank
time
you.
and in delightful session for to join us. Thank you, sir.
Thank you. Thank you to all of you.
Okay, sir. Sir, we are leaving. Okay.
Okay, I'm also.
Okay, sir. Okay, sir. Thank you.